Okay, we're on page 82. This is the bottom of page 82. We're going to do numbers 11 through 17. And the first few we're going to add and subtract, and then we're going to summarize what we learned about using the greatest common factor and least common multiple when solving adding and subtracting problems. So here's my whiteboard. And if you forgot how to add and subtract fractions, if you forgot about common denominators, I'd encourage you to go back a couple pages, go back a couple videos, check out the introduction video where I taught you how to add and subtract using common denominators. I'm going to go ahead and go through that right here. Watch the video a couple times if you need to. So we're on number 11. It's 3/8 plus 5/24. And because I'm pretty good at my my multiples here, this one's going to be pretty easy for me. Check this out. I know that the least common multiple of 8 and 24 is 24. So what does that mean? It means all I need to do to get a common denominator is I need to multiply my denominator here by 3. So watch what happens. If I do 8 times 3, I get 24. Now this fraction, I will have a denominator of 24. You have to multiply the numerator by the same thing. So I get 9 24ths. Now I can rewrite my problem here as 9 24ths plus 5 24ths. And remember that you add just the numerators. 9 plus 5 is 14. So I get 14 24ths. And so right here we used LCM to get the least common denominator. Now I'm going to use GCF, the greatest common factor of 14 and 24, to simplify. The greatest common factor of 14 and 24 is 2, so I divide by 2 to simplify. And 14 divided by 2 is 7, and 24 divided by 2 is 12, and so my answer in simplest form is 7/12. So good job on number 11. Let's check out number 12. Number 12 is 1/20 plus 5/12. And I didn't write 20, but I can real easily. So now I recognize that I don't have common denominators, and I need common denominators before I can add the numerators. So I'm going to do the multiples of 20 and 12. And I'm going to do the multiples of 20. I get 20, 40, 60. And I think that might be the answer, so I need to do my multiples of 12. 12, 24, 36, 48, 60. Notice I said 60 in both lists. So my common denominator will be 60. So once again, I'm using the LCM of 20 and 12. How did I get from 20 to 12? I mean from 20 to 60, I multiplied by 3. So I multiply this whole fraction by 3, I get 3/60. And I multiply this whole fraction by 5, because 12 times 5 is 60. So I multiply the numerator by 5, I get 25. And this is addition. I just always go back and check my sign. It's addition. So now I add my numerators. 3 plus 25 is 28 60ths. So again, I used LCM to get my common denominator. Now I'm going to use GCF to simplify. The greatest common factor of 28 and 60 is 4. If I divide by 4, 28 divided by 4 is 7. And 60 divided by 4 is 15. The answer is 7/15. Now if you did everything the same, but you divided by 2 right here, you would have gotten 14/30, which simplifies even greater. So that's why I divided by 4. It's just faster. Alright, let's check out number 13. Number 13 is 9/20 minus 1/4. Alright, this is another fairly easy LCM problem. The LCM of 20 and 4 is 20. You can simply get that by going times 5. So check this out. 9/20 can remain 9/20. And I'm going to subtract that. If I multiply all of these terms in this fraction by 5, I would get 5/20. And this is the first subtraction problem, so pay attention that we're not adding. 9 minus 5 is 4/20. Now I divide by the greatest common factor of 4 and 20. 4 and 20 are each divisible by 4, so the greatest common factor is 4. 4 divided by 4 is 1, and 20 divided by 4 is 5. That's the answer, 1/5. Alright, number 14. We'll leave that one up here. We'll check out 14. We've got another subtraction problem. We've got 9/10 minus 3/14. And this is going to be our first fairly complicated multiple problem. So what I'm going to do here is I'm going to list my multiples of 14. And I use a multiplication chart for this. This really is a lot easier if you use a multiplication chart. I'm going to go ahead and write LCM right here. The LCM of 10 and 14. I'm not going to do my 10s because 10s are easy. 10s are all the numbers that end in 0. 10, 20, 30, 40. But I do need to do my 14s because I don't have those memorized. So if I use a multiplication chart, I would know that it's 14, then 28, then 42, then 56, then 70. And I know I'm done there because 70 is obviously a multiple of 10 because it ends in 0. So that's my LCM, 70. So I can rewrite this as my denominator will be 70. And then you just have to ask yourself, it's not magic that you get from 10 to 70, it's multiplication. So how did I get from 10 to 70? I multiplied by 7. So everything in that term needs to get multiplied by 7. 10 times 7 is 70. 9 times 7 is 63. And then how many times do I multiply 14 to get to 70? It's the fifth multiple, watch. That's the first multiple, second, third, fourth, fifth. That means I multiplied it by 5. So you multiply this by 5. 14 times 5 is 70. 3 times 5 is 15. Now if you can't do 63 minus 15 mentally, you need to subtract it off to the side here, because this is a subtraction problem. Pay attention to the signs. 13 minus 5 is 8, and 5 minus 1 is 4. It's 48 70ths. And I suspect, I'm not positive I know this right off the top of my head, I suspect the greatest common factor of 48 and 70 is 2. So I'm going to divide by 2. If I find out that I'm wrong, I can always divide more later. 48 divided by 2 is 24, and 70 divided by 2 is 35. And 35 and 24 don't share a factor, so that's the answer, 24 35ths. All right, we are on number 15. Got 2 more to do, plus a word problem at the bottom, and then we'll be done. So good job on this page. Number 15. It's 3 3/8 plus 5 12ths. And do you remember that we can just ignore that 3 for now? I'm going to follow the same steps I always do. What is the LCM of 8 and 12? If I do my multiples of 8, I go 8, 16, 24. And if I do my multiples of 12, I go 12, 24. So I don't have to work too hard to get my multiples of 8 and 12. 8 is times 3 to get to 24, which means I multiply the 3 by 3, and I'd get 9 24ths. 12 is times 2, so I multiply the 5 by 2, and I get 10. This is addition. If I add my numerators, I get 19 24ths. And don't forget about this 3 right here. The 3 is the whole number. The answer is 3 and 19 24ths. Alright, number 16. This is another slightly tough one, but a multiplication chart makes it all the easier. If you're not doing these with multiplication charts, you probably should be. 5 7 tenths minus 5 18ths. We're going to ignore the 5. We're not going to worry about that right now. We are going to worry about our denominators. Our denominator is going to be bigger than 10 and 18. We need to find the multiples. If I did my 10s, it'd be 10, 20, 30, 40, 50, 60. I need to do my 18s. 18, 36, I think it's 54, 72, 90. I think that's right. Actually, not 100% sure, but I think that's right. I do know, this one I am sure of, I do know that 18 goes into 90. And I do know that 10 goes into 90. And so I know the LCM is 90. So I'm going to multiply 10 by 9 to get 90. So I have to multiply the numerator by 9 to get 63. And this is subtraction. And to get from 18 to 90, it's times 5. And so I multiply the numerator by 5, I get 25. So I'm just about done. I simply now need to do 63 minus 24. And that's going to be over 90. And so I borrow and do 13 minus 4, that's 9. And then I've got 5 minus 3, or 5 minus 2, that's 3. So I'd have 39 90ths. And a lot of kids think that'd be the right answer. It almost is. So think about the 5 here. 5 minus, there's nothing here. It's like it's 0 here. 5 minus 0 is 5. So I'm going to put my answer over here. 5 and here's my numerator, 39 90ths. And that is almost the answer. The problem is that 39 and 90 share a factor of 3. And that's not too hard. 3 goes into 39 13 times, and 3 goes into 90 30 times. And so my simplified answer for this somewhat challenging problem is 5 and 13/30. Okay, I'm going to leave those up. I'm going to go ahead and I guess I have a little line here that I'm going to get rid of too if I can grab it. Having a hard time grabbing it, so we'll live with that line. It's not a big deal. It says, how can, number 17, how can knowing the GCF and LCM help you when you add, subtract, and multiply fractions? Well, what was I doing? You use LCM to find. Did you hear me when I tried to use that word a lot because I knew this question was coming? You use LCM to find what? You use LCM to find common denominators. Now, you only find common denominators when adding, subtracting, so we need to probably write that. You use LCM to find common denominators when adding, subtracting. And then how to use GCF. And you use GCF when simplifying. You simplify by dividing by the GCF when simplifying fractions. That's a really good answer. Let's reread it and make sure it makes sense. You use LCM to find common denominators when adding and subtracting, and you use GCF when simplifying fractions. All right, good job. We are done with page 82.